Alright, so in this video, in this short video, we are going to go over how to factor difference of squares. So that's another factoring technique, part of this chapter. So a difference of squares is an expression that can be written in this form. That is, some quantity A squared minus some other quantity squared. And it factors like this: A minus B times A plus B. Let's go over a few examples just to illustrate how this works. All right, after a while, most of these are going to be piece of cake to factor, but in the meantime, if you are barely learning this, well, it would be a good idea to write the terms as something squared minus another something squared. That is, what quantity squared gives us x squared? Well, in this case, x, and what quantity squared would give us 9? Well, in this case, 3. All right, so all we do, so this is going to be our A, and this is going to be our B. All right, so A minus B times A plus B. In other words, simply x minus 3 times x plus 3, and we're done. This is how we factor this difference of squares. Let's do the same thing for letter B. Well, notice both quantities here are perfect squares. If you notice the number 16 and the number 25 as well. All right, can you write this? Can we rewrite this as some quantity squared minus some quantity squared? Well, let's find out. What quantity squared would give us 16y squared? I would say 4y. What quantity squared would give us 25? Well, I would say 5. This is our A, and this is our B. All right, let's factor this difference of squares as A minus B, A plus B, for y minus 5, and times 4y plus 5. And that's how we factor another difference of squares. All right, so letter C, let's have a look at this one. Well, if you look at the numbers 50 and -8, well, right away, if we try difference of squares, it's not going to work because the numbers 50 and the number 8, they are both not perfect squares. So let's try something else first. I'm going to factor a GCF first. So notice they are both even numbers. That means I can do I can factor out a 2, leaving us with 25 minus 4x squared. All right, and now we can tell these are differences of squares. Okay, so let's write this as something squared minus something squared. In this case, 5 squared equals 25, and 2x equals 4x squared. So don't forget these two right there. Keep writing it down. This is 5 minus 2x, 5 plus 2x, and we're done. Okay. Let's do another more. Well, let's do another one. All right. How about this one? Well, keep doing the same. Quantity squared minus another quantity squared. Okay, what quantity squared would give us x squared? Well, simply x. What quantity squared would give us 1/4? Well, that's 1/2. Let's write this as a factor form. Well, x minus 1/2 times x plus 1/2. All right, as simply as that. The very last example, well, notice the powers. We have power to the 4th. Well, so first we begin by writing this as some quantity squared minus another quantity squared. All right, so what are we going to have here? Well, we're going to have the quantity whose squared is p to the 4 is going to be p squared. And the quantity whose squared is 16, that's going to be 4. So when we do the first factorization, we get p squared minus 4, p squared plus 4. All right, so we are essentially done except for something. Well, notice in this case we can still break this one up. All right, we can still break this one up as another difference of squares, which factors as p minus 2 times p plus 2. Now we are going to leave this p squared plus 4 like this because this is a sum of squares. And sums of squares cannot be factored any further. All right, and this is all we need to know about this section, right? Goodbye.